Hi, at Chapter 5, Multi-Step Equations and Inequalities, and we're on the last section, and we're going to be solving, in Section 5.5, we're going to be solving multi-step equations and inequalities. We have a few vocabulary terms, so let's take a look. If we scroll down here, one term that we're looking at is called the null set, or, well, let's get the pen. It's called the null set or the empty set. And that's when an equation has no solutions. There's no way to solve the thing. There's no numbers that's going to work or no numerical answers that'll fit the variable. We say that the solution is the empty set or the null set. We use the following symbols to represent this situation. So you can have curly brackets with nothing in it, or you could have this. Kind of a zero with a line through it, and they both represent something called the null set or empty set. There's nothing that can satisfy that equation. Another type of equation that we have is an identity. It's an equation that is true for every value of the variable. So really quickly, I'm going to kind of give an example. Here's an equation that we're used to. 2 plus t is equal to 5. There's only one thing that's going to work here. 3, right? We can write 3 in a bunch of different ways, but really it's 3, right? So this has one specific answer, and that's 3. But what if I said 2 times some number t is equal to 2 times some number t? Well, anything works there. If t were 1, it would be the same. If t were 3 or 9, negative 2, negative 4.75316, doesn't matter. So this is a situation that's called an identity. Do you notice something about it? It's like looking in the mirror. What you see on one side is you see on the other. So when we get to an identity, recognize that you'll see something like this. And since we're talking about it, something with the null set situation would look like this. Let's say I had 2t plus 5 is equal to 2t. Should look fishy, right? Because you've got 2t plus something is equal to 2t by itself. This doesn't make sense. If you were to work on it and actually start trying to solve, you'd subtract 2t from both sides, and you'd end up with 0 is equal to 5, which we know is untrue, right? And so when we have an untrue statement that is obviously false, we know that there's no way that that can be true at all as you're trying to solve. Then you know that you have an empty set. So we'll see that example a little bit later. Let's take a look at our first example, example 1. In example 1, we're going to solve equations and inequalities with parentheses. When you have situations like this, like the one in part A, you want to simplify the right and the left side of the equation. Right and left. You want to simplify the right and the left side of the equation completely. And when we simplify, we get rid of parentheses. How do we do it? You know it. We distribute. We use a distributive property. So 3 times d is 3d, and then 3 times 2 is 6. All of that is equal to 12. Now we can get down to solving like we're used to. D is the variable that we want to isolate. To get D by itself, 6 has to go. So we've got our D terms over here, our constant terms over here. If I want my constant terms over here, I'm going to have to let 6 come and join it, right? And I get rid of 6 on this side by adding the negative. Remember the additive inverse, that whole conversation? So we've got 3D is equal to a positive 6. Finally, we're going to divide both sides by 3. Because we got to get rid of the 3 that's being attached by multiplication, so we divide, and then we are left with d is equal to 2. Let's go ahead and check this out as we consider an inequality. When we have an inequality, we know our rules for solving inequalities. The only thing we have to worry about is multiplying or dividing both sides by a negative. That's when we get the flip here. So we always keep that in mind. But otherwise, this really looks like an equation. So I'm going to kind of draw a dotted line down the center. We're going to do what we need to do. On the left side, we're going to distribute. So when I do that, I get 4x minus 12. And now the parentheses are gone. This is as simple as I can have this side, and still the orientation of this inequality is the same. I am now going to decide that I want my x terms here and my constant terms here. That means that this 12 has to go. It's a minus 12, so I'm going to add 12 to both sides. I have 4x is now greater than 6 plus 12, 18. To finish this problem, I need to solve by dividing both sides by 4. And I always ask myself, is 4 a positive number in this case? Is the number that I'm dividing on both sides of an inequality positive? Yes, it is. So there's no flipping of the sign. I just keep it moving. And then the 4 goes into 4 one time, so I'm left with 1x, and that's greater than 18 divided by 4. 4 goes into 18 4 times with a remainder of 2. over 4. So I can write this as x is greater than, let me reduce that 2 over 4, 4 and a half. X is greater than 4 and 1/2. Here in example 2, we have a similar situation, except now we've got parentheses on both sides, so we need to simplify and be really careful with our simplification. So again, we need to distribute to get rid of the parentheses. We're going to do that on both sides. So when I have that, I've got 4x plus 20 is equal to 3 times 2, 6x plus 3 times 4, 12. At this point, drawing the line, deciding which side I want my x terms on, I can choose any side, but I do like to choose the side where there's more x terms because it just keeps the coefficient of x positive. I don't know, but you can try it the other side. It'll be fine. You'll just get a negative coefficient. You'll divide by negative. Life will be fine. All right, so we've got x terms here, constants here. Constants here, who needs to go? You do 4x. So I'm going to subtract 4x from both sides. As I do that, I'm left with a 20, which is good because that's a constant term, and that's equal to 2x plus 12. The next thing I'm going to do is honor this side and say I only want x terms, so this 12 has to go. I'm going to add a negative 12 to both sides, and I get 8 is equal to 2x. And when I get that, I'm going to divide both sides by 2, and I find out that x is certainly equal to 4. And I feel really comfortable and confident with that. Let's go through the steps again. We simplified both sides, and then we process through like we usually do. We choose one side for our x term, and then the other side for our constant term. Let's check out this application problem. In this problem, example 3, we have Mariella, and Mariella's parents have budgeted $575 for her quinceañera. The cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receives a $5 party favor? There's a lot going on here. Let's see if we can organize our information. The first thing is that the family has $575. So at the end, everything must equal $575, right? So let's put our 575 here with an equal sign. What's going on? Each guest has to get 2 things. They've got to get some food, and they've got to get a party favor. But of the 575, already $75 has been spent on the room. So in addition to that $75, we need to feed and allow our guests to get a party favor. So that's 40 people will get both food, I'm going to use F, and a party favor, 5. So they'll get whatever amount of money they need for food and then $5 party favor. Look at this equation and make sure it makes sense. Don't just copy it down and go through the work. Make sure it makes sense. $575, 75 of which you need to pay for the room. For each guest, then you need to pay for something for each guest. What is that something? Party favor and food. And we're trying to figure out how much money will it cost for each guest to get fed at this particular event. So we have an equation and we're going to solve it like we do any other. Again, I like to draw a line down the center. 575 is as simple as possible, but this side can be simplified. When I simplify, I'm going to get rid of my parentheses and join like terms. 40 times F, 40 times 5. I'm going to use the distributive property there. 40 times F is going to give me 40F, and 40 times 5 will give me 200. And so now I can join some like terms together on this side. Still not completely simplified on the right side, but we're getting there. So we've got 275 is equal to 40. Oh, no, we don't. Lied to the children. Hold on. This is better. 275 plus 40F is equal to 575. And so now we can solve. So I'm going to subtract 275 from both sides because I'm going to leave my F terms on this side and I'll put my constants over here. So if my F terms are going to be on this side, I need to move all my constants in. 575 minus 275 is going to give me 300. And then I have 40F left over here because the 275 is gone. Now that I have that, I need a little bit more space. Let me do some magic here. Okay, so made that a little bit smaller. Now I have 300 is equal to 40F. I'm going to divide both sides by 40. And when I do that, F is alone. And so the cost of the food would be 300 divided by 40, or 30 divided by 4, if you guys kind of get that, and the answer is 7.5, or 7.5. So it looks like it's going to cost $7.50 for the food for each party goer or each quinceañera goer. Let's look at our next example, example number 4. We're going to solve multi-step inequalities. So again, whenever I see that I'm solving an inequality, I really want to keep in mind what happens when the sign is negative if I multiply and divide both sides by a negative number. So as I look at this, 5a minus 8 is greater than or equal to 4 times this quantity. I need to simplify both sides of this inequality. So the left side is good, 5a minus 8. That's fine. I can't simplify that any further, but you guys know by now we're going to rock the distributive property and get rid of the parentheses. So I have 4a minus 12. And then what I'm going to do is move things accordingly. So I want my a terms over here, and I want my constant terms over here. Okay, so when I do that, I need to subtract 4a from this side and subtract 4a from this side, and I have a minus 8 is greater than or equal to a negative 12, and then I'm going to add 8 to both sides, and then a is greater than or equal to negative 4. I do want to have like a little quick digression. So if I had 5a minus 8 is greater than or equal to 4a minus 12, if I chose to put my a terms on this side and my constants on this side, I'm just going to draw a line so we don't get confused, then what would happen is I'd subtract 5a here and then subtract 5a here, because I only want constants on this left side if I started in this way. It's not wrong to do it this way, just a little different. Please follow. So now I've got negative 8 is greater than or equal to negative 1a, or negative a, minus 12. I only want a terms here, so this 12 has to go. I'm going to add 12 to both sides, right? So I end up with a positive 4 is greater than or equal to a negative 1a. I didn't ask to solve for negative 1a, I asked to solve for a, so I'm going to divide both sides by a negative 1. And when I do that, a is for negative 4. What symbol should I have here? I hope you know that if you were in this case, you'd have to flip your sign. This is like one of those wah, wah, red alert type moments. You need to flip your sign. And this is what we get. Notice we get the same answer. A is on the open. Remember, the alligator's eating the larger amount. A is on the open end of our inequality symbol, and we have that on both sides. So I just wanted you to see that. All right, let's go ahead. I think this is our last example, or our last two-part example. It'll be fine. Solve each equation. We're going to simplify each side. Let's do that. So here's what I get when I use the distributive property. Now I'm just going to join some like terms. When I join these guys together, I got this. Aha, look at here. It's like they're looking in the mirror. Get it? Identity. We talked about it before, right? So this is an identity. Any number I put in here is going to work here because both sides are exactly the same. Our final example, let's go ahead and do the thing. We're going to distribute here and simplify. So we need to join our 4s and our negative 9s right there. Now that we've got this, look carefully. You've got a negative 5s minus 14 is the same as a negative 5s plus 6. Let's go ahead and choose one side for our s terms, the other side for our constants, and see where we go. I'm going to add 5s to both sides. When I do that, things fall apart. I end up with negative 14 because the 5s cancels out here and cancels out here is equal to 6, which is just crazy talk. This is false, and we know that the answer to this is the null set. And we've got two ways to do it, so that there is no answer, no real answer. I like to put real. Guys, have an excellent day, and I look forward to seeing you later. Take it easy.